think now you should be able to hear me and see my screen. Yes, okay. So yeah, what I was explaining is the overall syllabus, like how it is distributed in static part and dynamic part. Static part is more of the free body diagrams and friction, application of equations of equilibrium and trusses. Okay, whereas the dynamic part is like studying more the theorems like D'Alembert's principle, work energy principle, impulse momentum principle, and problems related to it. Okay, so that is overall your syllabus. So let's try to understand some basic things so that we'll be able to study all these topics in detail in upcoming sessions. Okay. Mm. So first of all, you should know uh, that the mechanics is what is meant by mechanics, and uh, how mechanics is divided into two major categories. Okay. Yes. Yeshwant, any doubt? No. Okay. So what is applied mechanics, or you can call it engineering mechanics as well? It is branch of engineering which deals with the effect of external forces applied on a body in any state, whether in any state means like whether it is in rest or so just a minute. um, I have connected. Again, I'll connect through my mobile as well. Okay, just give me a minute. I think it should work fine now. Let's hope. Um, yeah, so mechanics is, as I said, branch of science or engineering which deals with the effect of external forces applied on the body, and those forces are applied when body is either in motion or at static. Okay. Let's hope now. Hello, can you hear me now? Yes. Okay. So what I was explaining is static means body either is in body is in rest, and in dynamics body is in motion. Okay. And mechanics is dealing with both the approaches. So in static part, body is in equilibrium, it is not moving, so we can apply equations of equilibrium directly there and understand the effect of external forces. Okay. Whereas in dynamics part, okay, on the right hand side you can clearly see here, let me use a laser pointer, we have a dynamics part here. Body will be in motion, so you cannot apply equations of equilibrium there. So our focus will be like divided into two parts. One is kinematics and kinetics. Kinetics is branch of dynamics that deals with the effect of um, the external forces on the body. We can say without considering the forces, basically we have to understand the effect, like uh, on the body we will focus only on displacement, velocity and acceleration part, whereas in kinetics we'll understand the effect on the body considering the external forces which are causing that motion. Okay, so that is a difference, or this is the difference in between these two branches, kinematics and kinetics. Kinematics means without considering the forces, kinetics means considering the forces. So in kinematics part we'll focus on displacement, velocity, acceleration, so relationship between them, constant velocity problems and variable velocity problems. So our focus will be mainly on that. Okay. um, Rectilinear motion, circular motion, all these part we'll study in this. And whereas in kinetics part, as we are focused on the forces, our approach will be to understand the different theorems first, like which are related to the forces, such as work energy principle, impulse momentum principle, D'Alembert's principle, and understanding the problems on this topic. Okay, so this is the overall distribution of the syllabus and the subject. Okay, any doubt till this? If you have any doubt, feel free to ask in either in chat box or you can ask me directly. Not sure today. My network is little bad. Screen share is getting ended again and again. Please excuse me for it. Um, we got one question here. Let's try to answer it. Um, in kinematics, the net forces can be uh, considered zero. So Yeah, means here our focus is not on the forces. Okay. um, in kinematics we'll focus on like uh, on the properties such as like velocity, acceleration, displacement. So we'll not talk about the yeah, we'll talk only about the motions there, like not the forces, work done by the force, or let's say impulse created by force. All these things will not study there. Here we'll talk about the velocity. So for example, if I throw a stone at some initial velocity at particular angle, what will be the velocity after certain time, what will be the maximum height it will go, how much long it will go. So all these kind of things, um, all these things we will be studying in the kinematics part. Is it clear, Pranjul? Yeah. uh, and yeah, we do consider the forces in kinetics part. Okay. Yeah, correct, Abhishek. Only the effect of forces will be considered in the kinetics, and in kinematics we will not consider the forces. We'll just study the motion there. Okay. So let's try to understand the things in little more detail. uh, in mechanics you will not study anything such as stresses, strains, deformation, um, deflection, or anything such as such, because the assumption here is body is rigid. Rigid body means what? Rigid body means that body where if you take any 2 points within the body, even after application of the forces, the distance between these 2 points will not change. Okay. So then we call it as a rigid body, or in other words it's a non-deformable body. Okay. And that is our assumption throughout this subject. So that's why it's like very comparatively simpler than the other subjects. Like for example, in strength of materials, you will study stresses and strains there. And why? Because their body is deformable, and is the practical let's say assumption. And there you will see strain is getting generated, and because of it stress will happen. Okay. But here we are not talking about deformation or deflection or any as such. Our body is rigid, so it will not deform. And so what we'll study here is like the effect of it, like um, maybe let's say body is at rest, and how much amount of force we need in order to move the body. Our body is moving, how much amount of force we have to apply in order to stop the body. Or let's say if a system is there, in that if you are applying certain force, how much moment that force is creating, and all these things. Okay. So our focus is mainly on the forces and moments. Okay. Forces and moments. Clear? So this is our focus: force and moment. In if you study, let's say, other difficult subjects, or uh, the subjects which are based on this, such as strength of materials, machine design, or vibrations and all, um, you will calculate stresses, strains, and that comes from this. Okay. So if you know the force first, how the force uh, let's say calculate the resultant force and all basic things, then only you will be able to calculate how much stress and strain will be developed. Okay. So most of your subjects, this mechanics is very important. It will be uh, basic subject for rest of your core topics. Okay. So keep that in mind, and while studying all this. Yeah. Another um, another point is, let's say some laws we'll study now. Okay, some basic laws in order to study this subject, such as Newton's laws. Okay, and we also study couple of laws which are related to the force system. So let us take an example here. We have an example of a body, and we applied a force P at point A. Okay, and the red line indicates here line of action. Okay, uh, line of action is the line which is along the force direction. I hope you are getting it. So now, what is this law of transmissibility of force? This law states that if if body is there, rigid body is there, the state of the body will remains unaltered or unaffected if the force acting on the body is replaced by another force having same magnitude and direction but acting anywhere on the body along the same line of action. Okay, so so if I replace this force P at point A with the force P at point B, okay, and the point B is on the line of action, okay, and the force P is same, you can clearly see its magnitude is same and direction is also same. So we can say that the state of body will not alter, okay, or will remain same, because we are applying the force along the line of action. Okay, are you following it? So why it is important? In some cases, let's say you can simplify the problem if you use this law of transmissibility of force. Okay, when you draw the free body diagram, it will be easy for you to let's say apply these forces and make the figure simpler in order to understand overall force system. I hope it is clear. I'll repeat the statement. The state of the body or state of the rigid body will remain unaffected if the force acting on the body is replaced by another force having same magnitude and direction, okay, but acting anywhere on the body along the same line of action. Okay, so this is the main idea for this law. Now, one more thing here we should know is what is the limitation of this law. This law is applicable for the external forces. Okay, we got yes, Pranjal. In this case, body will remains unaffected. Means, for example, let's say because of this force, body is moving in left direction. Uh, if I apply same force, let's say at point B, body will also move in the left direction. Okay, or for example, or let's say body is at rest and we have some friction and we are applying this 10 Newton force here and it is not overcoming the friction. So frictional force, let's say in this case, is again 10, and so these two systems. So I'll replace that 10 Newton force from point A to point B. The body state will be remains unchanged. Okay. So that is what I'm saying. We are not talking about strain and all, because here the basic assumption is body is rigid. Okay, we will just talk about whether it is moving or at rest. If it is moving, how far it will go, okay, how much work done will do, and if it is at rest, whether it will move with that external force or whether it will remains at rest, how much frictional force it will generate, and all these things we'll study. Okay, not about the strains and stresses. So I hope you understood the law of transmissibility of force. And now, what is the limitation of this law? That is what we have to understand. Limitation is it is applicable for the external forces. Okay, not for the internal forces or internal stresses developed within body. Okay, so let's take an example here. I have one good example. Sure. Give me a minute. Yeah, so we have a body, let's say in this form, and at point A and point B we have compressive loading. Okay, so maybe what we are doing is we are reducing the temperature, or let's say because of some uh, internal contraction, body is getting contracted, and we have compressive loading here. Okay, but according to this law of transmissibility, what we can do is we can transfer this force P from point A to, sorry, transfer this force Q from point A to point B, and similarly we transfer this, similarly we can transfer this force P from B to A. Okay, and how it will look like if we do that. So if you do that, Q will be here and P will be here, right? And both are satisfying the condition of let's say law of transmittivity of force, because we have kept the same magnitude, same direction, and same line of action. But here the effect is completely different. You can see here in first figure they are producing compressive force, but in second figure what is happening is now they are producing a tensile force, right? So transmittivity affects the internal forces, and hence you should not use it for the internal forces. I hope you are getting what I'm trying to tell you here. Okay, so this is what happens. Okay, the entirely the effect will change if you apply the law of transmittivity of force to the internal forces. Yes, you can ask the question, Darshan. Yeah, you can ask, you can unmute and ask, or you can type if you have any question. Okay, feel free. But if any external forces are there, then you can do it. But if internal force is there, then you cannot. Okay, because of this reason. Yes, Darshan, you have raised your hand. If you have any doubt, feel free to ask. Yeah, I lowered your hand. If you have any doubt, ask directly. Any doubt till this? Is it clear to you all? The Yeah, okay. Okay, Abhishek, just to let's say so what you can say, just to, yes, yeah, I'm not saying that for non-rigid and deformable bodies also we have to apply. Okay, first of all, yeah, you are right that transmissibility law is not applicable for the non-rigid or deformable bodies. Okay, that is another, that is completely different point. I'm not saying that um, let's say uh, in case of non-rigid in case of non-rigid, basically we cannot apply. That is clear. Fine. But let's say, let me try to explain through some different things so that you'll understand. I'm talking about the internal forces, okay? Not not just the external forces. Let me um, try to draw one more diagram here. Just give me a minute. My screen share got ended. I'm sharing my screen. Yes, okay. So what, suppose the same example I'll take now, and let's put it this way now. Mm, Maybe like this. This is your line of action, and now at this point apply both the forces, P and Q. Okay. So let's maybe consider this figure number A, figure number B, and figure number C. So what I'm trying to explain is principle of transmissibility of force is not applicable in finding the internal forces. Okay. For example, in case of figure number A, P and Q are tensile. Okay. So if you consider this beam AB, in this beam AB, forces P and Q produces tensile force, while in figure B, let's say they are producing compressive forcing or compressive force, and then if you let's say consider the figure number C, there is no internal force. Okay, suppose if the magnitude is same, in that case you'll say there is no um, any internal force here. Okay, so that is let's say we cannot capture here whenever we talk about the internal forces. Okay, external you can do. Okay, whenever you are finding the internal forces, in that case only you cannot apply this. Okay, because you cannot say whether the forces are tensile or compressive or no internal force. That conclusion you cannot make. But if external forces are there, then you can make some conclusions, because you can easily uh, move the force from one point to other point on the line of action. Yes. Yeah, is it clear? Yes, if it is producing, right? Yeah, internal forces are produced, like you can, they are not applied. External forces are applied. Yes, I'll work on my network tomorrow. Yes, don't know why it is happening today. Let's continue to the next point. So we have studied the first law, law of transmissibility of force. Now we'll understand the law of parallelogram of forces. Okay. Um, so um, let's try to write the statement first. The law states that if two forces are acting simultaneously at point O, if two forces are acting simultaneously at point O on a body and are represented in magnitude and direction by two adjacent sides of parallelogram. Okay, so So for example, if this force P and force Q we have, which are applied on point O, we can clearly see this is like two adjacent, these are the two adjacent sides of the parallelogram. Then what law of parallelogram of forces says that the resultant is represented by the diagonal here. Okay, I'll repeat the statement. If two forces acting simultaneously at point O on the body are represented in magnitude and direction by two adjacent sides of parallelogram, then the resultant R is represented in magnitude and direction by the diagonal of parallelogram. Okay, and how you'll calculate this diagonal R? R is calculated by under root of P plus Q square plus 2PQ cos of theta. Okay, under root of P square plus Q square plus 2PQ cos of theta. Write down the formula. Yeah, we got one question here. Where is law of transmissibility of force is used? Okay, so Ganesh, like whenever you are solving the any problem, let's say static problem, for example, and in that case you are drawing a free body diagram. Okay, and then it will be very easy for you to let's say draw the free body diagram and put the forces properly in order to avoid the confusion. Okay, let me just maybe give an example here. I'll go to the previous slide. Yeah, so yes, suppose this is the block B and or let's say block of weight W. Okay, let's call this um, block which is of weight W, and if you are drawing the free body diagram, then what will happen? The weight will act downward, right? So either you can write W here or you can also draw here. Okay, it's your choice wherever you want to draw. And for this is a simple case, but if any complex problem comes, then this law of transmissibility helps you to make your figure simpler or make your free body diagram simpler, and you can easily calculate the total force in that direction. Okay, so in this case either you can write weight here or you can also write here, or and let's similarly the reaction which is created by the surface you can draw here, or normal reaction, or you can also draw here. Okay, so whichever you want. Okay, yes, yes, someone is for calculation. Yeah, that is what I was trying to explain. So you can easily draw the figures, free body diagrams. That is what you can say. Okay, any doubt in law of parallelogram as well? I hope it is clear. Here the angle between two forces is theta. Yeah. So what is the resultant here? Anyone? Resultant is what? Resultant force is like if the number of forces acting on the body are replaced by a single force which has the same effect as that of these total forces, then that single force is called as resultant. Okay, so for example, if let's look into this figure. If you have a body, in this body or on this body you're applying some forces, some are in this direction, random forces at any direction or any magnitude, and because of these external forces something will happen to body. Okay, some effect will happen to body. Means whether body will move in some particular direction, something like that. Same effect is created by a single force. Okay, then that force is called as a resultant. Okay, in simple words. So definition will be, if system of forces acting on a body, if it is replaced by a single force which has the same effect as these total forces, then such single force is called as a resultant. Okay, so here we have two forces, P and Q, and then this R is, so P is trying to pull this in this direction, Q is also trying to pull this in this direction. So if you replace P and Q with a single R, same effect you will see. Okay, I hope it is clear. Then we have law of triangle of forces and law of polygon of force. Okay, hello, yeah, just a minute, I'll law of triangle of forces and law of polygon of forces. Yeah, share my screen. Yeah, law of triangle of forces. Okay, so law of triangle of forces state that if two forces P and Q, yeah, if two forces P and Q, let's say, are represented in magnitude and direction by two sides of triangle. Okay, P is here, okay, and then Q is here. Um, they are basically acting on a body at particular point O. But if you are representing them in the magnitude and direction by two sides of triangle, then the resultant will be the closing side. Okay, the closing side will be the resultant, but in opposite direction or opposite order, you can say. Okay, so here P is in this direction, Q is in this direction, and this is the closing side, right? But resultant will be, yeah, closing side, but it will be in just opposite order. Okay, so that is what you should know. Yeah, so you can correlate here. If let's say this Q I am drawing here, rather than that, if you draw it here, what will happen is resultant, of course, should come here, right, in this direction. So same here you are getting, but you are just putting this Q not here, but at this tip, to make two adjacent sides of triangle taken in order, then the resultant will be in the closing side, just in the opposite order. Okay, and same law you can use for the polygon. Okay, so statement is same, that let's say, if the number of forces, so here F1, F2, F3, F4, are represented in magnitude and direction by the sides of polygon. So F1 is in this direction, F2 is in this direction, F3 is in this direction, F4 will be in this direction, as shown in this figure, first figure. So then resultant will be the closing side, but taken in the opposite order. Okay, the resultant will be the closing side taken in the opposite order. Okay, so yeah, I hope it is clear. Law of triangle of forces and law of polygon of forces. Any doubt in this? Okay. Okay, Rishabh is asking why we are taking resultant in opposite direction. Rishabh, can you tell where the resultant will come for these two? Will it come in this direction or in this direction? Let me, yeah. Whether it will come like this? No, it will not come, Rishabh. Direction, how direction will come like this? So if I have a body, right? And if I apply force like this, if I pull in both these two direction, how it is equivalent to pushing, right? Yeah, it will obviously come outwards, right? So now imagine that you are removing this Q from here and drawing here. This Q you are removing from this side and putting here like a parallelogram. So now where should you expect the resultant? It should remain same, right? Are you following, Rishabh? Uh, yeah, so that is the assumption here. Okay, I'll repeat the statement if you have not listened. If these two forces P and Q are, let's say, acting on some point O, okay, but they are represented in magnitude and directions by two sides of triangle, which are taken in order, then the closing side will be the resultant, but in opposite order. Okay. Yeah. Screen is not visible. Let me share it again. Yes. I hope it is clear till this, at least the law of triangle of forces. So same logic is applicable or extended to the polygon of forces. Okay, nothing different. Same logic you are applying for the law of polygon of forces. Okay, so here we have, let's say, four system of forces: F1, F2, F3, and F4. Okay, they are applied or acting on a body at point O, for example, but you are representing it in the magnitude and direction by the sides of polygon. So this is a kind of polygon, right? So F1 is one side, F2 is another side, F3 is another side, and F4 is another side. So these are the four sides of the polygon. Then the closing side of the polygon will be the resultant, but taken in the opposite order. Okay. Are you following? Who was asking it? Damesh, is it clear? Pranjul and Damesh. Yeah. Okay. Yeah. Feel free to ask if you have any doubt. So here, let's say, if you understand the law of triangle, same thing is. Hello. Not sure what is happening. Yeah, we'll wait. What we'll do is let's continue for some time, and if it's still breaking in between, then for today we'll close it little early. Okay. Yeah. Next point is resolution of forces. Write down heading resolution of forces. So suppose if you have force F which is acting on a body at point O, you can resolve that force into two components. Okay, resolving means splitting the forces or subdividing the force into two components without changing the effect on the body. Okay, so whatever effect is created on the body because of this external force F which is acting at angle theta with respect to horizontal at point O, same effect will be there if you replace this F with the two components of it, that is Fx and Fy. Okay, Fx is a horizontal component, Fy is a vertical component. You are just splitting this force into the two components. Okay, so Fx will be F cos theta and Fy will be F sin theta. Okay, you know, just by using trigonometric, we are writing Fx and Fy. Yes. Okay. The one more point you should know is how you should consider the let's say sign convention here. Okay, so sign convention, like if force is in the rightward direction, you consider it as a positive. If force is in left direction, you consider it as a negative. Same applicable, if force is in upward direction, you should consider as a positive. If it is in downward direction, you consider it as a negative. So whatever sign conventions we have for the coordinate system, that is positive, negative, positive x, positive y, negative y, same sign conventions are should be used for the resolution for these forces basically. Okay, so if you are resolving the force, let's say, maybe let me just yeah, so for example, this is the force you are resolving. So this is F1, let's say it will F1 cos theta, and this is F1 sin theta. Theta is here. Then this F1 cos theta will be the negative. Okay, so whenever you are dealing with such multiple forces, if you are considering a force which is then, if you are considering this as a positive, you should consider this as a negative. Okay, the one which is, let's say, going in rightward direction, if you are considering it as a positive, the force which is acting in the leftward direction, you should consider it as a negative. Okay, same logic you have to apply for the forces in the upward and downward direction. Okay, so that is also one basic thing you should know. Moment of a force. Okay, so when the moment will generate, whenever we are applying a force at certain distance. Okay, so here let's take an example. We have one certain force, okay, applied at certain distance from the, let's say, this fixed point or hinged point. So because of this, what will happen, this force will create some moment, and the value of moment will be the force into displacement. Moment is what? Moment is nothing but a turning effect or rotational effect created by a force if it is applied at a certain distance. Okay, so here what you can see is this is rotating in clockwise direction, right? Force here, it may create a counterclockwise moment. Okay, it may create a counterclockwise moment. So if we are considering one moment as a positive, then other moment has to be considered as a negative. Okay, So if you are considering clockwise as positive, then you should consider counterclockwise as negative while performing your calculations. I hope it is clear till this. The next point is couple. Couple is more or less same thing as that of moment. Okay, so whenever two equal forces, two equal and opposite forces separated by a certain distance d, it creates a moment. Okay, or it creates a couple, you can say. So the value of couple here again the same, F into D. F is the force and D is the distance between these two forces. Okay, so you can clearly see this is creating a clockwise effect, right? Let me draw here. Yes, right. You can just by the arrows of these forces, you can imagine how the turning effect will be created here. It is clockwise, right? So couple is, let's say, equivalent to a moment F into D. So you can say that the two forces of magnitude F but in opposite direction and separated by distance D, creating this couple. Is it clear till this? Any doubt? So here you should just understand how the sign conventions you have to use. If one thing you are considering as positive, other should be negative. So yeah, we got one question here for the law of triangle of forces and law of polygon. These laws are applicable for the forces acting at a point on a body. Okay, remember, not on the different points. Okay, if it is on the different points, it will create the moments and things will be little complex there. Okay, I will explain you once we study the let's say force system, that is coplanar, non-coplanar, collinear, non-collinear and all. Then here we got two questions. Okay, FD is work done. No, Ranjan. Uh, there is a difference. Okay, let's say this is F and this is D. In this case, it work done, right? Is it correct, Ranjan? What I am saying is yeah. What I was explaining here is you should not get confused with the force into displacement. Force into displacement is work done. That is different altogether topic. And here what I am trying to say is how much amount of force you are applying and what is the distance between these two forces. Okay, so D here in couple is the distance between these two forces. I hope it is clear to you, Ranjan. We got one more doubt. What is the difference between couple and moment? Yeah, you can say they are same. Okay, Shubham. Because if you do, let's say, the complete effect of it, summation of all vertical forces will be 0 because both of them have same magnitude. So it will not create any, let's say, force in the upward direction or vertical direction. It only creates the couple, okay, or a turning effect out of it. Yeah, we got one more question. What is torque? Let me just explain you through one simple figure here. Okay, so we got one rod here, for example, or maybe simple. Yeah, let's take a horizontal figure. A little bit easier for you to understand. Okay, so this is x direction, this is y direction, and this is z direction. So if I am revolving this rod about z direction, so what will happen? It is like a moment. Okay, moment about z direction. If I am revolving this rod about y direction, you can call it as again moment. That will be moment about y. But if you are rotating it, or if you are making a turning effect out of, let's say, about z direction, in that case it will be the torque. Okay, so if you are turning the body about its axis, then you call it as a torque. Otherwise it will be a moment. Is it clear, Ranjan? Okay, we got one more question here, Abhinav. How can there be a resultant moment out of a couple if couple construct two balance opposite direction forces? Yeah, because they are separated by a certain distance d. If two forces are, let's say, one here and one here, there is no moment. But if you start increasing the distance between them, you can clearly see a moment. Let's take a simple example. Okay, take a pen in your hand and try to push the pen from both the sides. At a single point, you will not see pen is turning. But now if you take a pen and put it on a table and try to apply force like this, you will see pen will rotate, right? It will turn. Abhinav, are you following? So you put a pen like this and try to push it here and here, then you will see it will rotate. Yeah, Aman, yes, I'll repeat once again. So torque, you can say, if you are turning a body about its own axis, it will create a torque, right? And but if you are turning about some other axis, then it creates a moment. Okay, we call it as a moment. Torque is, general term is moment. Torque is a moment about the axis. Okay, I hope it is clear now. Yeah, so this is all about the moment. Yeah, a couple of basic things like some more basic things we'll study before we end session. Today we'll end session early as I'm facing the network issue. Just give me a few more minutes and we'll study a couple of basic things which are remain. First law, second law, and third law. Newton's first law. So what is Newton's first law states? That you should know that if body is there, it will continue to be in the state of rest or uniform motion unless and until you apply an external force acting on it. Okay, that is what the first law says. Okay, so whenever you have a body which is at either rest or in the uniform motion, it will remain same. It will continue to be in rest or uniform motion unless and until you apply some external force to change it. Second law states is that rate of change of momentum of a body is directly proportional to the impressed force, you can say, or in general you call it as F is equal to ma. Okay, mass times the acceleration. And third law is Newton's third law is for every action we have equal and opposite reaction. Just for an example, if you are putting a block of weight W on a surface, then the surface also will give an equal reaction force on a block. So if you draw a free body diagram of a block, how it will look like is this: R will act as upward and weight will be acting downward, or in other way you can write it like this. Okay, so this R is a reaction from the surface. Okay, so these three basic laws we have studied from 10th. You should also know them. Just to revise it, I have explained. And yeah, the last part which I'm going to explain today is force system. Coplanar and non-coplanar, there are two kind of force systems which we have to understand first. Coplanar is if the forces are within the plane, okay, within a single plane, then you call it as a coplanar force system. Okay, means if I'm drawing any forces on this two-dimension paper or two-dimension figure, then you call it as a coplanar force system. But if some forces are coming out of the plane, then in that case you call it as a non-coplanar force system. Okay, what is concurrent force system? If the forces are passing through single point, then you call it as a concurrent force system. Okay, and if forces are not passing through single point, for example, let's say this is the beam. In this beam, one force is acting downward, one force here acting upward. They are separated by a certain distance. They are not passing through single point, right? So here, this is a non-concurrent force system. So this situation can come in coplanar as well as non-coplanar force system. So that's why a broader classification looks like this, that coplanar concurrent force system you will have, or you will have a coplanar non-concurrent force system, non-coplanar concurrent force system, or non-coplanar non-concurrent force system. Okay, so this is how you'll have the different kind of force systems. In our syllabus, we only have the coplanar force system because we are dealing with the figures which we can draw in two dimension. Okay, coplanar means if within all forces are in the single plane, in XY plane basically. Okay, and either they can be concurrent or non-concurrent. Concurrent means passing through single point, non-concurrent means they are not passing through single point. Is it clear till this? Yes. Any doubt? Feel free to ask. So if I say a coplanar concurrent force system, this is how it will look like. Whether any moment will get created here? No, because all the forces are passing through single point. So whenever this kind of force system is there, we'll talk only about the forces. Okay, we'll deal only about the forces. We'll not deal with any kind of moments in first situation, that is coplanar concurrent force system. But in case of coplanar non-concurrent force system, we will study not only the forces but also the moments. Okay, because let's take an example here. This force F1, which is at a distance d1, creates a clockwise moment. This force F2 at a distance d2 creates a counterclockwise moment, right? So basically, whenever forces are not passing through single point, what it will create, it will create a moments as well. So here we will deal with forces as well as moments. Clear? So depending on this, whether you have a coplanar concurrent force system or coplanar non-concurrent force system, you have to understand which equations of equilibrium you have to apply and solve the problem. Because in coplanar concurrent force system, there are no forces. Sorry, there are no moments. So you can just use these two equations of equilibrium. Okay. Before that, just to let you know what is equilibrium. When we say body is in equilibrium, if net force on the body in all the direction is zero, right? In x direction, if summation of all the forces in x direction is zero, summation of all the forces in the y direction is zero, summation of all moments is zero, then basically body is at rest. Sorry, basically body as a rest or as at the equilibrium, you can say. Okay, body is in equilibrium, correct word. But if that body is subjected to the coplanar concurrent force system, you will be dealing with only summation fx and fy. Okay, so only these two equations of equilibriums are used in coplanar concurrent force system. But if you are dealing with the coplanar non-concurrent force system, one more equation will come, that is summation of all moments is also equal to zero. Okay, so this is what you should know, and we are talking it about the coplanar. Similarly, if it is non-coplanar, fx, fy, fz equal to 0 will come in concurrent, and in non-concurrent, mx, my, mz will come into the non-concurrent. Just for your information, if you should know that what are the equations of equilibrium you can expect in non-coplanar force system. Okay, we will not be studying any problems on this, but theoretically you should be knowing what equations of equilibrium will be there in non-coplanar, because coplanar, you know, summation fx, summation fy, and summation of all the moments are zero, which are in xy plane, means about z axis. Okay, so similarly in non-coplanar, not only x y, but also summation of all the forces in z direction you have to consider, and the moments about the other axis also you have to consider, and those should be also zero when we say the body is in equilibrium in case of non-coplanar coordinate system. Yes, Pranjal, you can write down the equations of equilibrium. Summation of all the forces equal to zero. Summation of all the forces in y direction is also equal to zero. Summation of moments is zero. Yeah. In case of concurrent force system, you will deal with only these two equations, but you will, in case of non-concurrent force system, all three equations are used. This is the difference. Okay, this is not useful for us in concurrent force system, because in concurrent force system moment will not be generated. Clear? Yeah. Okay. Let me see if we have any other point to discuss. Just a minute. Yeah, let's take a simple question. Try to solve this. The resultant of two equal forces P acting at a point is also equal to P. Okay. Very simple question. Determine the angle between the forces. Very simple question. Yeah, in degrees, yes, you can. How 90 degree will come? No, just don't throw answers randomly. Try to think. Yeah, we have some people saying 90, some 120, some 180. Some some people are saying 30 degree. Any other answers? 60. Okay.
240.
No. Okay, 240. Let's see. Have you drawn the figures, all of you? At least to see. Yeah, 120 is the correct answer here. Um, at least you should draw the figure and see how it looks. Okay. Let's try to draw the figure randomly. If I draw one 90 degree, okay, suppose one force is P, another force is P. How their resultant will be? This will be their resultant, right? It is of course not equal to P. We know it is under root of P square plus P square. So it is root 2P. Okay. If I say the resultant is root 2P, then 90 is the correct answer. So try to think what will be the resultant. If you bring it closer and closer to this, what will happen? Your resultant will also, let's say, go on increasing, right? Because it will create a parallelogram. Whenever you create an acute angle between the whenever you create an acute angle between these two forces, your resultant will increase. Your resultant will reduce when the angle is more than 90 degree. So if it is 180 degree, resultant will be 0, right? So 180 is absolutely wrong answer, because mm, you can clearly see this. You're pulling with this force here, and you're pulling the P with in the left hand direction, so it will be 0. So something in between 90 to 180 should be the correct answer. Okay, so you know the law of parallelogram forces. Resultant is denoted by under root of P square plus Q square plus 2PQ cos of theta, and here resultant is itself equal to P, and both the forces are also equal to P, so that is P square plus P square plus 2PP or 2P square cos of theta. Just solve this equation, nothing else. Okay, so if you square both the sides and solve them, you will get P square equal to P square plus P square plus 2P square cos theta. So basically this P square you can cancel, and cos of theta is minus 1 by 2 you will get, and 120 degree, that's all. Or you can just try to draw the figure and you will see how it looks, and then also you can judge, right? 120 should be the correct answer. Okay. Okay. . Yeah. And now, what is other possible answer? Yeah. Yeah. This can be an also correct answer. You can say. Um, how much it will be? Here the resultant also you can draw. Okay. Um, how much will be the angle? Yeah, it will be 240. Okay. Yeah, so that is also correct. But make sure what is mentioned in the problem and accordingly choose the answer correctly. Okay. So if options are there both, then you can choose it. If one of them is there, then you can choose it accordingly. Anyone have any doubt in this? At least you understood the approach, how to solve it. Yeah, draw the figure whenever you want to understand how this particular angle. Try to draw the figure and understand. So look at this. Okay. So this is x-axis, this is y-axis, and if this angle is 240, you can expect still same resultant in this case as well. Okay. Anyone have any other doubt? Okay. What is cos of 240? Minus 1 by 2. What is cos of 1 by 2? Or what is cos of 120? Again minus 1 by 2. Okay. So that is why both the answers are correct. Shrujana, is it clear? Yeah. Okay, good. Let me give you another simple question. Yeah, we have point O here, and we have 5 Newton force applied here. Then we have 7 Newton force applied here. We have 9 Newton force applied here. We have 11 Newton force applied here. We have 1 Newton force applied here, and we have 3 Newton force applied here. Okay, 1, 3, 5, 7, 9, 11. Okay, they are passing through a center of a regular hexagon, and as shown in this figure, determine the magnitude and direction of the resultant. Okay, so you have to find the magnitude and direction of the resultant. Yeah, if you know a simple basic logic, if we have some force Fx in the x direction and some force Fy, then the resultant of this force is under root of Fx square plus Fy square, right? So this is how we can calculate the resultant. If we know the forces in x direction and y direction, then the resultant will be under root of it. And what angle it will create is, yeah, of course, tan of Fy by Fx. Okay, this will give you the angle, tan inverse of Fy by Fx. It will give you the angle at which this resultant is there with respect to the horizontal. Okay, so this same law you have to apply here, but now you are not dealing with a single forces in x and y. You got multiple forces randomly distributed, so every force will have some x component, some y component. So you will have some total number of forces in x direction and y direction, their summation, and then you have to deal with the resultant. Yes, 12 is the correct answer. So summation of all vertical forces is what? Which are all forces will create the vertical? This 3, 5, 11 and 9. These four forces will create a vertical component, because this 1 and 7 is completely in horizontal, so it will not have any vertical component. So summation of all forces in vertical direction is 3, yeah, 3 sine of 60, because it is a regular hexagon, so this angle has to be 60, this also has to 60, 60, 60. Okay, so 3 sine 60 plus 5 sine 60. Okay, these two forces will have vertical component in upward direction, whereas the 11 Newton and 9 Newton force will have vertical component in downward direction. And so I should write it as a negative 9 sine of 60 minus 11 sine of 60. So if you solve them, you will get maybe minus 10.39. Okay, negative indicates the resultant or the summation total vertical force is in downward direction. Okay, downward. Negative means downward. X-axis, no, Vaibhav. 12 Newton is correct answer, but not on the x-axis. Check it again. Summation of horizontal is what? Yeah, now 1 Newton is on the left hand side, so I should consider the minus 1. Minus 3 cos of 60 plus 5 cos of 60. Okay, plus 7 plus 9 cos of 60 minus 11 cos of 60. Okay, anything is missing? No. And if you solve them, you will get 6 Newton. Okay, and the resultant will be under root of 10.39 square plus 6 square 12. Okay, and theta will be tan inverse of 10.39 by 6 to get a 60 degree. So it's something like this. Like this, something like this. Can you tell me why this direction? Check it if this answer is correct. Yeah. Why? Because our summation Fy vertical is downward and horizontal is rightward. So resultant will be in that quadrant, in this quadrant. Okay, this is our, go back and write. Summation horizontal is how much? 6 Newton. Summation vertical is 10.39. Resultant is 12. Are you following? Any doubt till this? Hello? I hope it is clear to you all. Let me check if you have any other question. Simple. Yeah. Okay. So the simple question is on coplanar concurrent force system where forces are passing through single point. One more question I'll take just to make you familiar with the how non-concurrent force system will look like. Okay. Anyway, we will be solving many problems later on, but for today's session, at least you should have brief idea of what we have studied till now. We have, let's say, a bar or a beam, you can say a beam A, B, then C, D, and D. Okay. We have 3 kilonewton force here, 2 kilonewton, 4 kilonewton, then we have 5 kilonewton acting at, let's say, 30-degree angle, and we have, let's say, 8 kilonewton acting at 45-degree angle. Okay. Distances are like 0.2, this is 0.4, 0.2 and 0.4 meter. Okay, you are from you it is expected that you should find the resultant in here, acting as it, considering it as a rigid body. You have to find the resultant and the location of the resultant also, if possible, try to find where the resultant force will come and at what angle it will come. Okay, so resultant, magnitude and direction. Direction and location. Okay, so this is the question. Try to find the magnitude, direction and location of the resultant for this figure. Anyone? Okay, so how many horizontal forces will be here? You can clearly see only these two forces will create an horizontal component because the rest of the forces are in vertical direction. So summation of all horizontal forces, if we do, it will be minus 5 cos of 30 plus 8 cos of 45, right? Because if you split this force, it will have two components like this, that is 8 kilonewton force, right? And and this should be also 45. And if you split this 5 kilonewton force, it will look like this. So that is the reason I consider this as a negative and this as a positive. In case you find it's directly written, this is the background behind it. So yeah, once you solve it, you'll get plus 1.326. Plus means it is in rightward direction. Yeah, 13.2 is the correct answer. Downward. Yeah, let's see. Summation vertical. Vertical are a lot of forces are there. Minus 3 plus 2 minus 4. Okay, because these are direct, we can write them directly. But these two forces, there will be vertical component. So minus 5 sine of 30 minus 8 sine of 45. Okay, and it will be minus 13.15 kilonewton. Minus indicates it is in downward direction. Okay, and then resultant is under root of 1.326 whole square plus 13.15 whole square. It will be 13.22 something kilonewton. Okay, and the theta will be tan inverse of 13.15, that is Fy by summation of all vertical forces divided by summation of all horizontal forces. Horizontal forces summation is 1.326 and it will be something like 84.24 degrees. Okay, yes, 84.23. So yeah, can anyone tell me at what location this force? So, yeah, this force is something like this, because it is clear that our horizontal is in this direction, vertical is in this direction, so resultant is something like this, making an angle 84.24 degrees. Okay, this is how resultant will be there, but at what location it will be? So here at this point we should know the Varignon's theorem. What is the Varignon's theorem? Write down heading Varignon's theorem. What Varignon theorem states that the moment of resultant about any point is equal to sum of the moment of all the forces about the same point. Okay, are you following? Moment of the resultant about a point is equal to sum of the moments of forces about the same point. Okay, so let's take, you are considering reference point as A. Okay, so you are considering at point A. Let's take this, let's take all the moments about point A and then solve the problem. So what are the moments which are generated about A? Can anyone tell me? Minus 2 into 0.2 plus 4 into 0.6. Then the horizontal component of 5 Newton and 8 Newton will not create any moment. So only the vertical components will create. So that will 5 kilonewton will create a positive, 8 kilonewton will also create a positive moment. So 5 sine of 30 into 0.8 plus 8 sine of 45 into how much, 1.2. Okay, this is the moment, total moment from this all the forces, and this should be equal to the moment created by the resultant. Okay, so resultant will again have vertical component and horizontal component. Horizontal component of the resultant of course will not create any moment, so only the vertical component will create. And what is the vertical component? Minus so it is downward, that is 13.15, and we don't know, let's say somewhere it is acting at a distance x from the point A. So now if you solve the value, solve this equation for the x, you will end up with a certain number. Okay, and that is 0.82. Okay, and yeah, so 0.8 is somewhere here, so 0.82 will be somewhere here. Okay, so somewhere here in this particular direction the resultant will be, whose value is 13.22 at an angle of 84.24, and this is at a distance of, let's say, 0.82 meter. Okay, we got some questions here. Let's try to answer them. Pranav is asking minus or plus for the last two moments. So I'm taking moments about point A. So 2 kilonewton will create a counterclockwise moment, right? It will create a counterclockwise moment. 4 will create a clockwise moment. Here the resultant will be like this. Sorry. Here the components will look like this, right? Here also the components will look like this. So it will basically create again the clockwise moments only. I hope it is clear, Pranav. Both let me, yeah, both 5 Newton and 5 kilonewton and 8 kilonewton have downward vertical component, and that is the reason it is creating a clockwise moment. Is that clear to everyone? Yeah. So one new thing which we have studied is Varignon's theorem. You should know. If you have not written the definition, I'll repeat again, write down, or the theorem statement. The moment of the resultant about a point is equal to the sum of moments of all the forces about the same point. Okay, this is Varignon's theorem, very important. Okay, yeah, it's good that now connection is better compared to what we have in the beginning. So let's take advantage of it and try to cover some more topics. Okay, some basics of free body diagram I will explain now. Free body diagram. In this name we have free body. What is the meaning of free body? Generally what happens is body is resting on some supports or attached to some threads or anything. Okay, so you can say body is resting against various supports, and if you remove all these supports and replace by their reactions or forces exerted on them, on the body, then such a body is called as a free body. Okay, and diagram which shows this is called as a free body diagram. Okay, I'll repeat the definition in more detail if you want. If a body is resting against the various supports, and suppose all the supports are removed and replaced by their reactions or forces exerted by them on the body, then such body is known as free body. Okay, So free body is now isolated body, right? Because we are removing from the supports. If two bodies are in contact, one is supporting the other. So if you are making it free, means it's an isolated body from the surroundings. And a diagram of an isolated body which shows only the external forces exerted on the body is known as free body diagram. Okay. So it is a sketch of the free body along with the external forces acting on it. Let's take simple examples first, and then we'll make it little more complex. Let's take a very simple example. If we have a ball of weight W resting on horizontal surface. So how the free body diagram will look like? The free body diagram of this block will be or this ball will be ball. You have removed the horizontal support here. Weight will act downward, and R will be the reaction of the ground. Okay, are you following? Yeah, okay. Let's make it a little more complex. Okay, this is the bar. This is the ball now. I'm keeping in this kind of surface. Okay, in this kind of surface, which is at angle theta to the horizontal, and the block is again of weight W. So how the free body diagram will look like? You will remove this basically all supports. Yeah, so the weight will act downwards. Here we will have perpendicular to this surface, we have an reaction. Let's call this surface as surface A, this surface as surface B. So you'll have an RB here, and you will have an RA here. Okay, RA basically here, but yeah, like this. Let me use the red pen to highlight. RA, we have RB, and then weight is acting downward. Okay, so if angle between these two is theta, then angle between their perpendicular should also be theta. So this angle has to be theta. Clear? Any doubt in this free body diagram? Okay, let's make a little bit more complex. Suppose if we have a ball, same ball now, but now it is resting on a vertical surface, but because of this thread. Okay, we are connecting it through a thread, and this ball is of weight W, and which is also, let's say, touching the surface A. So surface, we should draw it like this. Yeah, so we have weight acting in downward direction. RA force will be like this, and we have a tension in the string. Okay. So we have weight W acting, we have RA, and we have um, tension in the string as well. Okay, so this is how the free body diagram will look like. Clear? Any doubt? If no doubt, then one more example I'll take. Okay, this is an inclined surface. A block is kept on it, and P is the force which we are applying. Okay, and it is at an angle theta. So how the free body diagram will look like? Okay, so this is the block. Weight of the block is W. Okay, if this angle is theta, this also has to be theta, and we are applying by force P. Okay, any doubt in this? Are you following? And we have one vertical reaction as well. This reaction coming from this surface A, let's call the surface A RA. So we have weight of the block W, P force, and the reaction. Similarly, let me draw one more figure. Let's say like this, and we have one. Just a minute. Yep. This is point A and point B. How the free body diagram will look like? Anyone? Okay, suppose this is a bar of weight W. Okay, bar of weight W. So weight will be acting at a CG, center of gravity, W. Okay, and at point A we will have horizontal reaction RA, and at point B we'll have a vertical reaction RB. Okay, so here both, yeah, we have one horizontal reaction and one vertical reaction. Is it clear? Any doubt? Okay, we got some comment here from Weber. Sir, friction force will be there. Okay, I'm not saying that this surface is rough or anything. Okay, so let's assume it has smooth surface. Okay, without any, I have not given any coefficient of friction here, so don't consider friction in these cases. In rod case also, yeah, if let's say if we have a smooth surface, again the friction will be zero. The friction force will come, yes, only when we have a rough surface. So let's take an let's say suppose surface B is rough. In that case, what will happen is frictional force will also come. Because of the weight, what it will happen is this rod will try to go down like this, and this B will try to move in rightward direction. So frictional force will be in leftward direction. Okay, this is F friction, you can say, or frictional force F. Okay, and that will be equal to mu times the reaction. Mu is the coefficient of friction. We'll study about it in more detail when we study the friction topic. But as of now, as we have not yet studied friction, assume that these are smooth surfaces without any friction. When I bring the topic of friction, we'll study what is coefficient of friction and what is the maximum frictional force and all in detail. Any doubt till this? Is it clear to you all? Okay, good. Yeah. One last point we'll study and then we'll end the session. Or let me check the timing. Yeah, I think we are at the end now. Let's end session here, and we will continue again on Thursday. Okay. If you have any doubt till this, we have 2 more minutes. We can 1 or 2 more minutes. I can wait and then we can end the session. Okay, and sorry for the disturbance here because of network issue. In the next class, I'll make sure that we'll have a smooth connection. Okay. Any doubt? Can we close the session here? If no doubts, then we'll end our session here. Yeah, thank you all for joining this class, and let's meet again on Thursday. Thank you. Bye. Good night.